First video was basically on properties of logs. The first half of the packet and this half of the packet is focused on log equations. Again, the videos that I've been recording, it took me like hours, had no audio, so I had to do voiceover on these, so bear with me if it's not perfect. So it says logarithmic equations, type 1, we're doing log equals log. The steps are right here. Condense each logarithm. And then step 2, right, so you should have log equals log. So if you notice in the first three problems, it's log equals log. But in 4, right, there's 2 logs on one side of the equation. So that's where the condensing comes in. And then after you condense it, you use the one-to-one property. So if log base b of m equals log base b of n, then m equals n. So we're going to write that in there. And then after that, you solve and check for extraneous solutions. Basically, you want to check to see like if the inside is negative. So they're already equal to each other, so you just set the insides equal to each other. 5x plus 9 equals 6x. Right, and then you just solve for x. And notice how all the equations, the bases are the same. It's like this only works if the bases are the same. So you subtract 5x, right, and you get 9 equals x. And then you plug it into your calculator. You're not really going to have any problems because 9 isn't going to make the inside of either of those logs negative, so x does equal 9, but just to show you, to check that you do get the same answer on both sides, you plug in log base 5 of 5 times 9 plus 9, and then see if it's the same as log base 5 of 6 times 9, right? And then you'll see that you do get the same answer, which I will be writing down momentarily. You get, 2.478 on the left side, and you get 2.478 on the right side, so it does work. You can see on the calculator that's what I did. Alright, so next one, set those insides equal to each other, so 1 minus 4n equals 2n plus 43. Subtract 2n to get 1 minus 6n equals 43. Subtract 1 minus 6n equals 42. Divide by negative 6, so you get x equals 7. So again, if you negative 7. So again, you want to worry about if the inside of your logs will become negative. You're not going to have a problem, but just show you all by plugging in your calculator, right, you get the same answer on both sides. So you plug in negative 7, you get 1 minus 4 times negative 7 the inside there, and then 2 times negative 7 plus 43 on the inside there. And then you get on your calculator 4.857 for both of them. So you can see I plugged in negative 7 and then for n, both sides of the equation. So here again, the logs are already condensed on logs on both sides, so set the insides equal to each other. Add 3w, so you get w equals 6. Now this time when you do plug it in, right, let's just watch what happens. So on the left side, you have log base 9 of 6 minus 3, and then we got 6 for w. And then you say it says non-real answers, right? That's because it makes the inside of the log negative, which is impossible. So this time, this answer is extraneous. So there are no real answers for number 3. So this one, you have 2 logs on one side, so you got to condense it using the product property. So it's y plus 5 times 4, which simplifies to 4y plus 20. Now they're condensed, so you set the insides equal to each other. 4y plus 20 equals 72. Subtract 20, you get 4y equals 52. Divide by 4, and you get y equals 13. And that does not make the inside of that log negative, so it's not extraneous. So y equals 13 is the correct answer. Again, like, see, if you plug in 6 to that side's also negative, right? You get negative 12 on the inside. That's why it's extraneous. Okay, they're both condensed, except for there's that 3 in the front, so you got to bring that 3 up. So that's log base 7 of 4 to the third, which is 64, equals log base 7 of 4a minus 8. Set the insides equal to each other. 64 equals 4a minus 8. Add 8, and you get 72 equals 4a. Divide by 4, and you get a equals 18. Here you can condense the left side. Plug it back in, and you'll see that 18 isn't going to make the inside of that negative, so that is the correct answer. You got to condense the left side, so use your quotient properly. So you got to do log base 4 of 68 divided by 4, which is 17. So rewrite that log base 4 of 17. Now both sides are 1 log, so you set them insides equal to each other. 17 equals 3n plus 11. Subtract 11, you get 6 equals 3n. So you get n equals 2. This one you got to bring up the 1/2, so that's log base 6 and then 25 to the 1/2 equals log base 6 of 23 minus 4w. Remember, 25 to the 1/2 is the same as the square root of 25, so that's log base 6 of 5 equals log base 6 of 23 minus 4w. And then now you can set the insides equal to each other, so 5 equals 23 minus 4w. Subtract 23, you got negative 18 equals negative 4w. And then divide by negative 4, and you get 4.5. Again, if you plug that back in, for w in the original equation, the inside of the log is not negative, so it's not extraneous. This one, you got to condense the right side, so you got to bring that 2 up, so that's log base 3 of 36, 6 squared. And then log base 3 of 4, so then use the quotient rule, that's log base 3 of 2p minus 5 equals log base 3 of 36 divided by 4, which is 9. And then now set the insides equal to each other, so 2p minus 5 equals 9. Add 5, you get 2p equals 14, and then p equals 7. Again, not extraneous. Next page. Okay, so these 9 and 10 are basically the same, except for when you set them equal to each other, you do get quadratics. So log base 4 of m squared, or you set, they're already condensed, so it's m squared equals 18 minus 7m, right? So you get a quadratic, so you need to set it equal to 0. So 0 equals m squared plus 7m minus 18. Then you factor it. We're going to review factoring later this week, but you're going to get to see my lightning speed factoring right now. M plus 9, m minus 2 equals 0. And then you get m, remember they're the opposite, so m is negative 9 and 2. And you might worry about that negative 9, but you plug it back, they're actually both, they both work. You're not going to get negative answers. So, so in this case, you have two answers here. Well, I'll show you. Like if you check negative 9, you'll get log base 4 of 81 on the left side, and on the right side, you also get log base 4 of 81. 18 minus 7 times negative 9 is 81. So yeah, they both work. All right, this one you got to condense the left side first, so that's log a or log of 2k squared equals log k squared plus 16. Set the insides equal to each other. 2k squared equals k squared plus 16. So since there's no middle term, you don't need to set it equal to 0. You can just isolate the k squared. So you subtract k squared and you get k squared equals 16. Square root both sides, you get k equals plus or minus 4. And they do both work. So okay, so the last one is log equals log. This one's log equals a number. So these are the steps. It says condense and isolate the logarithm. So these ones, 11, 12, those are condensed. 11 is condensed and isolated, but you can see for number 12, it's not isolated because you have this minus 7 right here. So you need to move that over. And then you write in an exponential form and solve and check. So here we're on step 2, so you just do the snail. So 2 to the 6 equals x minus 4. 2 to the 6 is 64 equals x minus 4. You add 4 and you get x equals 68. Here you can't do the snail yet. You have to, again, like here, the only thing that's inside the log is the 4x plus 8. So the minus 7 is outside the log. So you need to make sure the log is all by itself. So you need to add 7. So log base 3 of 4x plus 8 equals 4. Now you can do the snail. So 3 to the 4th equals 4x plus 8. And 3 to the 4th is 81. So 81 equals 4x plus 8. Subtract 8. And you get 73 equals 4x. Divide by 4. And then you get 18.25. Okay, here you have to condense the log. You have to combine them together. So that's use the product property. So that's 2x times x minus 5 equals 2. Simplify the inside first. So that's 2x squared minus 10x equals 2. Okay, and do the snail. So remember, log without a base is 10. So that's 10 squared equals 2x squared minus 10. So that's 100 equals 2x squared minus 10x. Divide everything by 2 and you get 50 equals x squared minus 5x, and then set it equal to 0 and factor, and you get x minus 10 times x plus 5 equals 0. And negative 5 doesn't work because it makes the inside negative, so just x equals 10 is the correct answer. So here you gotta condense the log, so bring up the 2, that's log of x squared minus log of 4 equals 2. Use your quotient rule, that's log of x squared over 4 equals 2. Use your snail, so that's 10 squared, so that's 100 equals x squared over 4. Multiply everything by 4 and you get 400 equals x squared, and then you square root it and you get x equals plus or minus 20. And then negative 20, right, doesn't work, so it's only x equals 20 because negative 20 makes the inside negative. Okay, here use the product rule. So that's log base 6 of x times x plus 9 equals 2. Simplify the inside, that's log base 6 of x squared plus 9x equals 2. do the snail, that's 6 squared equals x squared plus 9x. That's 36 equals x squared plus 9x. Set it equal to 0. X squared plus 9x, and then subtract 36. Factor that, then you get 0 equals x plus 12, x minus 3. So then you got x equals negative 12 and 3. Remember the opposites. But negative 12 doesn't work, right, because you're going to get the inside is negative. So only 3 works. Okay, last one. Log, so user product property, that's x times x minus 3 equals 1. That's log of x squared minus 3x equals 1. Do this now, that's 10 to the 1 equals x squared minus 3x. Then set equals 0, x squared minus 3x minus 10. 0 equals x minus 5 times x plus 2. So then x equals 5 or negative 2, but negative 2 doesn't work, so just 5. Because you plug it in, you get log of a negative number. See my lightning fast factoring. Okay, so these ones are exponential equations. We've done some of these already. We've done the ones of the warm-up here, right? So it says warm-up using common base to solve an exponential equations. So you can solve these by just making common base. See, like 5 and 25 have the same base of 5, and 9 and 27 have the same base. So you can just write 25 as 5 squared, and then you set the exponents equal to each other. So you have n plus 10 equals 2. Subtract 10, and you get n minus equals negative 8. And you don't need to worry about extraneous things, right? You can take exponents to a negative power. So this next one, they're both powers of 3, so 9 is 3 squared to the a plus 2, and then 27 is 3 cubed to the 4a minus 2. Now distribute the power, so you get 3 to the 2a plus 4 equals 3 to the 12a minus 6. Now set the exponents equal to each other, so you have 2a plus 4 equals 12a minus 6. Subtract 12, you get negative, oh, I guess I subtracted 2. So you get 10a minus 6, then add 6, you get 10 equals 10a, so a equals 1. Okay, now it says, what if a common base is not possible? So the other two, the common base is not possible. These was possible. So it says, isolate the exponential equation, take the log both sides, and then it says you may need to expand the log using the power rule. So this first problem, right, the first step is already taken. It's already isolated. You can see, like, 61 is not a power of 2, so you have to use this method. So you take the log of both sides. I'm just going to use log base 10 for all of these. You can choose whatever log you want, actually. It doesn't really matter. So you use the so log of 2 to the x equals log of 61. Remember, now you can bring down the power, so it's x times log of 2 equals log of 61. And then you just divide both sides by log of 2. So it's log of 61 over log of 2. And then you just do that part in your calculator and you get some gross decimal. So log of 61 divided by log of 2. And you get 5.930. That's your answer. So again, 8 and 91, right, or 92 are not powers of each other, so take the log of both sides. Break down the exponent. I minus 7 times log of 8 equals log of 92. Divide both sides by log of 8, so you get m minus 7 equals log of 92 over log of 8. Do that on your calculator. So m minus 7 equals 2.174. M equals 9.174 when you add 7. So here it says isolate the exponential expression. The other ones were already isolated, but this one, see, like 2 to the x is by itself, 8 to the m minus 7, and then 7 to the n there. See, the 4 is out there. You need to get rid of that 4 first. So divide both sides by 4, and you get 7 to the n equals 37. And then now you can take the log of both sides. So n times log, bring down the exponent, n times log of 7 equals log of 37. Divide both sides by log of 7. So you have n equals log of 37 over log of 7. Put that in your calculator. N equals 1.855. So this one you got to isolate the 3W by adding 5. So you get 43W equals 8. Log both sides, you get 43W. Log of 43W equals log of 8. Bring down the 3W. Get 3W times log of 4 equals log of 8. Divide both sides by log of 4. You get 3W equals log 8 over log 4. So 3W equals 1.5. Divide both sides by 3, and you get W equals 0.5. Phew, okay, so that's the last problem that I'm going to do. The last page you guys can do all on your own. You can just check the answers. I'll scan them in for you. So yeah.